One last review to prepare for your assessment. We started off talking about functions, and recall that for a function, every input can have only one output. So as you're looking at mapping or a table of values or ordered pairs like you see here, you're looking at your input and output values. Your input are your x's, your output are your y's, and if your input value is repeated, we see that we have 6 and 6 is repeated. It goes to 7, it goes to 11. So this input of 6 has two different outputs. It is not a function. And the reason being is that the input value of 6 has more than one output. It has two different ones. Look at the second problem, and again you're comparing inputs and outputs, but what you're looking at is a repeated input. Well, I have 5, 4, 3, and 5. Well, 5 is repeated, but in this case it has the same output. This is a function, and the reason being every input has exactly one output if you're asked for a reason. We then went into something called function notation, where we replaced y with f of x. So if we had an equation originally that looked like this, and we took y out and replaced it, and we had function notation, and now we're going to evaluate at a given point. So we're going to evaluate at 2. We're looking at a second function, and this is the rule. When we look at the rule here, we're going to replace and simplify. So when f is equal to 2, I'm going to get 6 minus 4. So when I input 2, my output was 2. In this one, I'm inputting 3. Add the opposite. So when I input 3, I output 2. This replaces doing that whole table of values. And you had one of these on your assessment review last night. If I give you a domain of, let's just say 1, 0, -1, and I give you that function, and we'll say y is equal to 3x minus 4. I replace one at a time. 3 times 1 is 3. 3 minus 4, -1. 3 times 0, minus 4, -4. This is going to give me a -3 minus 4, -7. This gives me ordered pairs. And what do I do with ordered pairs? I graph them. So this was the first way that we learned how to graph. And we found out that this way was a little bit long and could lead us to some calculation errors. So we learned the quick graph methods, which we'll do in just a moment. Before we get there, we had a review of rewriting equations and identifying slope. Then making the comparison of slope, saying, are they parallel, same slope, perpendicular, negative reciprocals, or neither, no relation at all. If I look at my first one, it's easy to identify my slope. It's already isolated. Second one's in standard form, so I'm going to add 4x to both sides. That gives me 2y is equal to 4x plus 2, and then divide all terms. That final solution here, final equation here will be y is equal to 2x plus 1. So I see my slope is 2, and I'm going to say that these are neither. There's no relationship there at all. On to our quick graphs. If I give you an equation in standard form and I ask for you to find the intercepts, set x to 0 and y to 0. When y is 0, I'm left with -4x is equal to -4. So x is equal to 1. There's my first spot. I then have to find my y value. So I get 2y is equal to -4. I'm going through this quickly because yesterday it seemed like everyone understood, but I felt the need to do a couple more practice problems today. And then we connect. We just need 2 points, and we see that this is a -2 and a +1, and we have a positive slope because it's going uphill. It's rising. Second problem, let's find those intercepts. To find the x-intercept, y is equal to 0, so I've got 3x. Oh, that's a terrible x. Let's try that again. 3x is equal to 6, so x is equal to 2. Let's find 2 right there. Let's now find our y, and that's easy because if x were equal to 0, y is equal to 6. 1, 2, 3, 4, 5, 6. Connect the dots, and again, this time we see that we can name the slope by its form, and it's a negative slope because it's falling from left to right. On to our second type of quick graph, and that's when we identify our slope, rise over run, and our y-intercept. Graph the intercept first. Point on the y-axis, 1, 2, 3. Slope says to go down 2 and over 1, 2, 3. 2 points, you have a line. Negative slope, negative slope. Last problem on this slide, 5 and -2. Start graphing from your -2. Your slope is of +5. Remember, that's 5 over 1, up 5 over 1. 1, 2, 3, 4, 5, and over 1. Graph, positive slope, positive number. And the last thing I wanted to go over was our constants. If y is equal to 3, let's find y3, 1, 2, 3. Y is always going to be 3. There is your horizontal line, 0 slope. X is a constant, and it's always -4. 1, 2, 3, 4. And there is your line, and it is going to be a vertical line which has an undefined slope. And there you have all there is to review. Feel free to ask questions for additional review today.